Well, hello everybody, and welcome to today's webcast. We'll be talking about engineering remedies to improving your large assembly performance today with SOLIDWORKS. I'll be your host today. My name is Brian Vanderplug, and working here at Unitech for a good 15+ years as currently as the application engineering team lead and manager. So. Before I kind of get started a little bit and introduce myself a little bit more, as we go out throughout the webcast here in the next 30 minutes, feel free to access the Q&A box in WebEx, and if you have any questions, you can just chat those in the box, and then at the end of the webcast today, we'll kind of go through those and answer those questions. So feel free to chat those along as the webcast goes along. A little bit about myself. As I said, I've been working here at Unitech and using SOLIDWORKS for a good 15+ years now. Certified SOLIDWORKS expert and a myriad of other things that I've done with SOLIDWORKS. But really, in my role today is really leading the team that kind of helps you as customers understand and realize the benefits of SOLIDWORKS and the suite of software tools and solutions that we provide. So feel free to reach out to me if you'd like. I'd love to hear from you and answer your questions as well. If you see me out and about, a lot of times with new things coming along, again, yet another, we're still riding the dinosaur train here, but a lot of people for some reason seem to think that I resemble a much younger version now of the great Jeff Goldblum. So chasing dinosaurs is one of my hobbies, I tell people. So hey, today really talking about large assemblies with SOLIDWORKS. It's one of those topics that comes up often throughout the year. With a lot of new tools and tips and techniques and things, a lot of people are doing assembly work and getting into bigger things, right? We master something and we just want to go bigger. So, if you're starting to experience a number of different things, how do you know if you're in that realm of a large assembly? So, I won't go through all of these, but if you're experiencing some of these situations, that assembly might be consistent or considered large in your perspective. So again, a lot of people like to put a number on it. Is it 100 parts, 1,000 parts? It really doesn't matter. It really is based on, your experience using the tools of SOLIDWORKS, the hardware that you have in place, and whether or not you're getting acceptable feedback and response from the software is really what kind of dictates if you have a large assembly. So things like open and save times that are excessive, time to create drawings, trying to maybe transition windows, maybe you're getting a slow response as you're moving your model around. Those are just types of things when you have a larger assembly that you might experience and want to start maybe figuring out how we can remedy some of that. So that's what we're here to talk about today. Really kind of going over some of the tips that we'll cover is really into these 6 different categories. 30 minutes is really not a lot of time to get in really deep in the weeds in a lot of this. So really this presentation is going to be structured around a more lengthy series, which I'll show and highlight here in a minute, and also at the end of this presentation, that you can actually go and consume at your leisure after this WebEx, which really goes into more details about a lot of the things I'm going to talk about today. So we'll talk about your data and how it transfers into SOLIDWORKS, talk about your load times, things you can look at there, file conversions, error management, obviously the good old system settings, and then probably the big heavy hitter is really the excessive detail checkbox down at the number 5 there. And then also just start pointing you into some other tools that maybe you might go and look at someday when you get a chance inside of SOLIDWORKS. So like I said, I'll put the plug here at the beginning and at the end, but really a lot of this is based around something that one of our senior tech support engineers, Toby Schnaars, Some of you may join his tech talks that he does every month for Fisher Unitech. Great, very knowledgeable engineer and user of SOLIDWORKS for many, many years. But he actually put together a lot of this information in more detailed fashion, actually showing you in a video format how to go about and do a lot of this stuff. So really, here I'm trying to get you a taste of that, what some of these things are. If you want more information, I'm going to definitely point you out to Toby's YouTube series. So getting started, let's talk first about data transfer speeds. And so when we think about how we need to get something open in SOLIDWORKS, basically we're looking at a number of things, right? Where is the data being sourced from? So we think of traditional hard drives, maybe that top drive there, excuse me, that top drive there is maybe your traditional spin drive that we're accustomed to. The bottom one, a lot of you are very familiar maybe with the more common solid state drives now, which is kind of the newer, it's not really new anymore, but the newer style of hard drives that are maybe in your laptop or your desktop computers. And obviously then we also got to look out to the server environment, your network. So probably 9 out of 10 folks that are maybe listening today, or when we talk to customers, are still accessing their files off of a network share. It's very common. It's fine. It's how your data is backed up. But really, all of those things come into play when we're talking about data transfer speed. So if your organization opens files directly from the network, that network environment, right, the hard drive that's actually physically on the network server somewhere. And then you got to start considering, all of those little pipes that you see coming out of that data server to your user PCs, right? It's going through a, some type of pipe to get to your actual laptop computer, your physical computer, before it can physically open into SOLIDWORKS. So regardless of what method you're using, ultimately all of this information has to get opened into RAM on your machine. And so whether you have the file stored locally on your own physical hard drive, whether it's out on that network drive, basically what SOLIDWORKS is doing, Windows environment, right? We're opening that information, transferring that data into RAM. And so, a wise person always told me is the fastest computer, the fastest hardware is only as good as the slowest component somewhere in that chain. So if you got a slow switch from your network somewhere in the background that an IT person is only going to be able to diagnose, if that's the slowest piece in the puzzle, that's going to slow you down, right? If you have an outdated hard drive, you're opening it local, but you got a slow spin speed on your old spin hard drive, that could be your slowest component. So it's very tough. The hardware piece is very tough, where a lot of people maybe go and get the biggest, baddest computer on the planet, and then they don't really see much performance gain with their large assemblies. And so it's not always the situation of the physical computer you as a user is using. So the big thing I really need to talk about here is the network, right? So what we find as your value-added reseller is that, unfortunately, a lot of IT groups, and maybe there's some IT folks on the call today, don't necessarily understand all of the pieces of the puzzle that go into play, let's say, of opening a large assembly. And so, if we can eliminate that network transfer speed out of the equation, we're probably going to see a large gain immediately. So again, you could have the fastest solid state hard drive in your local PC that you use at your desk, but if all of your data is stored on the network, it doesn't really matter, because that data is never transferring across your physical hard drive. So you could have gone and built the best computer possible with the best, biggest solid state hard drive, but it never was really touching that at all. And so that doesn't really matter. So the data, I'll share some data along the way today, but really this is the large assembly that we use to benchmark a lot of this stuff. It's been around for a while. Some of you maybe been in the SOLIDWORKS channel a bit and have seen it before. But this is a huge assembly. This is 6,000 plus components. And so, again, a very simple test of us is when we put this on our own internal network at Fisher Unitech, almost 7.5 minutes to open this thing fully resolved. When we transfer the information over to our local drive, we drastically, immediately reduce that down to just under 2 minutes, simply by cutting the network out of the equation. I want to share this real quick just because it's kind of hard to maybe decipher this a little bit. But real customer data had a customer complaining of, oh my goodness, it's taken forever. I changed the names, obviously, a little bit here. But if you look down kind of the second column of each one of these sections, different plants of this organization, which are all trying to access. We did a benchmark on our actual assembly, very similar to what we ran. And you can see some of these guys that are in outlying plants, 35, 45 minutes to open their assembly. Ridiculous. You know, the guy, Luke Skywalker there was the lucky one because he was either in the same building as the server or you know, or the closest one. You know, he was getting it down to 10 to 18 minutes, depending on the time of day. But I think the thing to note here is they all said, we had the big, you know, again, we spent all this money, great PCs, they're all identical. And sure enough, when we got them to run a physical test to get it to a local machine, you can see all of their times to open are right within 4 to 5 minutes. Now, again, still a pretty lengthy amount of time. And there's other things that we'll talk about today that they definitely needed to do as well. But by simply taking the network out of the equation, you know, we could see anywhere from 2 to 9 times increases in open time, or decreases, I guess you would say, in open time, just to get it to a local machine. So this is one of the easiest things to test in your organizations. Is if you're diagnosing that perhaps your network is bogging you down with your large assemblies, it's the easiest thing to test. Pack and go your an entire large assembly, put it on your local C drive, and open it, and see if you get an acceptable gain in time by doing nothing else but that. So I highly recommend trying that out if you aren't using that. You know, one way, you know, from action items in this area to consider is if you are able to work locally, you know, take advantage of the most modern technology. Solid state hard drives are going to be a ton faster, anywhere from 2 to 4 times faster than your traditional spin drives. So definitely, if you're working locally, invest in a solid state drive if you can. Try to remove that network from the loop, right? Obviously, I know there's going to be a lot of people that are maybe in that situation. But this is also, if you're not using a PDM system, you know, a data management system behind the scenes, this is one of the main drivers behind that. And the customer on the slide ahead of this, it was a big driver for them to move to PDM. You know, so a PDM system is going to also help you cache the files to your local drive, so you then can hopefully take care of that, take advantage, I'll say, of that solid state hard drive in your machine, and get performance gains just simply from basically the data transfer speeds. So moving on into data load times. You know, obviously when we have parts that make up an assembly, you know, or those parts or assemblies make up a drawing. I didn't put a drawing icon on here, but the same thing is true. You know, so what goes into, you know, some of that also behind the scenes, right? So for instance, maybe we're working locally now, we got it down to just under 2 minutes. I want it fast, right? That's only fast to me for a couple of days, and I want it even faster. So what are some other things that we can start looking into? And data load times is one of those. So one thing that I'd recommend that you start looking at is actually just examining your data quickly. You can do this very simply in Windows Explorer. You know, one thing that we did here is we just look through and look for file size. So if we look at the different file sizes, what's highlighted over there on the right, you know, about an 8 meg or 8 gig file, it's a solid part file inside of SOLIDWORKS that's part of this assembly. So just examining the directory that we're using and taking a look at maybe what could be going on as to why that file size is so big. Sometimes there's no way around it. It's just maybe a big imported file, something like that. But is there something that stands out about that file? So a common thing that people overlook is this property inside of SOLIDWORKS. So this is a document property called image quality. And so this is a no-no right here. So if you go into your properties, you go to image quality and you take a look at where that slider bar is, it should not be way over to the right. So image quality is basically how sharp and tight are those edges, right? If you drag this thing all the way to the left, you know, a cylinder might look a little chunky, right? Might not look like a nice smooth cylinder. So I'm not asking you to drag this all the way to the left, but it should never really be all the way to the right unless maybe you're pinpointing for a particular file. So that's definitely the first thing to look at. The reason this can balloon your file size is this is a document property in SOLIDWORKS, which means it's stored within the file, which means it's going to boost the file size up because it's information that's contained within there for the quality of those parts. You know, so definitely something slid back more to the left. I find that if you're right in this range where you see the slider in the screenshot, typically your cylinders still look like circles, you know, unless it's a really small item or a small hole or something like that, you know, then you know, you might have to boost that up a bit. But I would definitely start by looking at that file, at that property. This should also be something that your CAD administrators are looking at in your template files. You know, you want to make sure that the part template that you use to start new files, where that's a stored property in your template. So make sure that slider is not way over to the right. So just by adjusting image quality, which you may have done this on purpose, you know, I brought that down to over 8 gig just to 5.5, right? So maybe another thing to look at is actually let's examine the file inside. So this file is actually the tire. In this situation that we purposely went in and put in a bunch of tread and patterned the tread, and we got extruded text for the sidewalls. You know, something that you probably wouldn't do, I hope, on a tire, but we're just trying to get the point across that these things make a difference, right? Do you got all your helical threads or even just cylindrical cuts to show threads on a bolt, right? I mean, that's probably not detail. It needs to be there, and it's going to balloon the file size up. So can you suppress it under unnecessary detail? In a minute, I'll talk about creating other configurations to do some of this. But by suppressing all of those complex features, boom, just like that, we brought the file size all the way down to, you know, minimalistic 300K. So you can see how something like that can really affect the file size, which again is going to really affect also how quickly things load. So another thing to really look at here is look at this setting to automatically load your components lightweight. So lightweight has been around for many years with SOLIDWORKS. It kind of gets you know, a mixture of good and bad reviews amongst the user community. But if you're using large assemblies, I would definitely recommend that you consider using this setting. And again, I'm going to look in the Windows Task Manager to kind of prove out how this works. So lightweight is basically only loading a subset of the information of the files necessary into RAM. So you're basically loading less information into RAM. So you go back to the first section we were talking about data transfer speeds. Well, now it's less data to transfer, faster to load, right? So not using lightweight, looking at my RAM usage for SOLIDWORKS after I opened this assembly up is about 3.2 gigabytes of RAM. Well, if I go and open the same assembly just by checking on load components lightweight, I reduce that over by almost half down to 1.6 gigabytes of RAM. So it's just loading less information into RAM for you to go through and basically decrease your load times. So some things to look at here, again, kind of going back, you'll see me do this a few times, but network, local with lightweight, we can get that load time down to 45 seconds. So right away, we're already under a minute doing some different things, and just the first two things to consider. So reduce file size of large parts, load components lightweight are big things to start considering here for your load times. So let's talk about file conversion and error management. So Obviously we have SolidWorks. We build a new assembly. It's pointing out to these different files inside of SolidWorks, right? We've just rolled out to 2018. We skipped 2017 altogether. So we went from 16 to 18 SolidWorks. Now I'm building this new assembly. I'm using components that were created from before, but perhaps never updated to the latest version. To compound that, now maybe I did a pack and go with something and it's got some made errors in it. Oh, this file over here has got a couple of errors in there. So this is just a recipe for, bogging you down. And so it's really tough to show gains and whatnot in here. You're going to see a 10 times gain by cleaning up all your errors. Probably not. But those types of things definitely weigh in on how long it takes to load assemblies in SolidWorks. So, when you open an assembly, it's going to tell you right away, right? With this screenshot, it's basically telling you, hey, this assembly file has not been updated to the latest version. So what's happening when SolidWorks opens that file, it's actually doing an up convert of those files. I don't know if that's a word, but it's up converting that, let's say, from 16 to 18 when you open it in 2018 SolidWorks. But if you choose not to hit the save button at all, you're basically negating that extra time that it took to do that up convert process. You're going to have that whole time to re-up convert it again the next time you open it. So if you go to save the file, you can go through and actually you can show a whole list of all the files that haven't been updated to the latest version. If you're using 2018 SolidWorks, they really did a nice job of redoing this performance evaluation tool at the assembly level, which will show you the exact number of documents as well and what files they are that are not yet updated to the current version of SolidWorks. And so the big thing here is, like, if you're doing that, let's say a more common thing is you're opening your large assembly and there's a smattering of sub-assemblies and parts that are throughout there that have not been up converted. And so you need to go through and get those things converted if possible. So work with your CAD admins as well on a process to go through that, or call us at Fisher. We can help you through that. The same is true for errors, right? So we don't really have a good baseline of like what kind of gain you can get here, but errors in your assemblies and parts cause delays. SolidWorks is trying to figure out if it can fix those issues, why it's opening the files, and when it can't, then it stays errored as an error after it comes open. And so it's just unnecessary thinking time, really, resolution time that SolidWorks isn't going to be able to do if you don't resolve those errors, fix your made errors, fix your feature errors, or suppress those items if they're not needed. So kind of not using lightweight here, so if we say, get all the files up to local and now 2018 version, you can see this is not using lightweight. We can drop it down to 1 minute and 15 seconds. So action items here, again, make sure your files are converted to the latest version that you're currently using. Try to remove any features and issues with that. So we're in a world of settings, right? So I'm an iPhone user. Oh my goodness, I can't ever keep it up to date, right? Another software update, there's 800 other settings that I don't know or got switched or turned off or on, all kinds of screens to look through, and it's basically an evening process to go through and figure that out. Unfortunately, SolidWorks is very similar, right? We got all kinds of system settings and document property settings. I already talked about image quality for you. And so these are things, though, that you really need to pay attention to because they can drastically affect how your assemblies perform. So the big thing, again, is maybe use the performance evaluation tools. It's really nice in 2018 because it'll show you what files and how long they're taking to open. If you're on an older version of SolidWorks, that was an enhancement in 18. So if you're on a 2017, 2016 version of SolidWorks, you can use the assembly visualization tool and filter it to show SolidWorks open time, and it's basically showing you the same information. But again, you can try to start troubleshooting which files are taking longer to open and why. And a big thing to look at is maybe going to File, Find References, and see, are all the files getting pulled from the directories that you expect them to get pulled from? And probably the biggest driver of time is this folder path in your file locations for referenced documents. So if you have a file path or paths in this reference document section of your system options, SOLIDWORKS is always looking into that folder to see if any of the files exist in there. So let's say you pack and go all of your files to a local folder on your desktop. But then somehow somebody put in a file path in this reference documents location. If any of the files, even though you have the large assembly saved to your desktop folder, if it finds any of those files in these reference documents folders, it's going to pull the file from the reference document folder first. And so this is a big drag, especially if this location is a network location, because it's recursively going through and searching that folder to see if any of your files exist in there, and it's going to slow down the process to get this open. Now, why does this setting exist in SOLIDWORKS? There's definitely reasons when you would use this. A lot of times it's when perhaps companies have moved files around to different directories, or they've migrated from one system to another. But really, realistically, you should try to avoid having any file paths in this directory. System settings display, hopefully your large assembly does not look like this. That's a little ridiculous, but hopefully you're keeping that clean, right? Turn off as much display stuff as you can, right? No fancy real view graphics, perspectives, planes, axes, sketches, right? Shaded mode only is the best. If you can turn off your edges even at the main assembly level, it's less or least taxing on your graphics card. So clean that up as best you can. Again, there's also a myriad of system options that we could go through. We could bore you to death. And so one thing to look at here, a number of things really, is some display options. Can you turn off, the screenshot should actually have this unchecked, but can you turn off dynamic highlight from graphics view, right? That's as you move your mouse over stuff, it's highlighting edges and faces. Can you turn off dynamic highlight in the feature manager? So again, that's when you're hovering over items in the feature manager, they're highlighting in the graphics space, right? And again, these are settings for large assemblies only. Keep that in mind. Performance, right? Can you turn off these, one or both of these, high quality for normal or dynamic view mode, right? So this is just if you have transparent components, things set to transparent in your assemblies. Basically, it's just like it kind of blocks it down. It still will look kind of transparent, but it's dumbing down the graphics, so to speak, so it's not as taxing on your graphics card. This is a big one, display. If you guys like to edit parts in context of your assembly, please, 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 please set this setting to opaque assembly. So a lot of times people will have it set to transparent. And so what that means is you go into edit part mode and it's trying to create, put 6,000 plus other parts transparent. Talk about a display killer at the large assembly level. So keep it opaque. You can even take it a step further and go into your colors and make the colors of parts change. Performance level of detail, if you slide the slider bar more to the right, that might be as you rotate things, you might notice parts kind of get chunky and blocky. Again, it's just kind of as you're doing movements like rotate, pan, zoom, it's dumbing down the graphics to increase your experience as you do some of those functions. So definitely move that slider bar. Finally, the same would be for view transition, right? We love it when we go from a front view to a top view, and SOLIDWORKS does that nice animation getting it to the top. Turn that stuff off when you get into the large assembly environment. When I go from a front view to a right view using a shortcut key, just boom, snap me to that view. I don't need to see this nice, beautiful animation of me going to that, and that's just going to kill your graphics, and it can be chunky. So this is where you would turn some of those items off. Same with hide show component. You could even do it for isolating, things like that. The last thing really to look at here too would maybe be using large assembly mode. So large assembly mode can have some of these settings I just discussed automatically kind of enable or disable based on the size of the assembly. So you can basically set this to a threshold. This screenshot shows 500 components. So if you open an assembly, you have this turned on with more than 500 components, it basically drops you into this environment called large assembly mode. And there's a number of things that you can have it do or not do when it does that. So read up on that a little bit and explore that. So again, a lot of actions here is really look at your file, find references. Is there some weird outliers, right? Eliminate unnecessary display items. Optimize your system option settings for large assembly usage, okay? And then if you can, really explore using the large assembly mode environment. So excessive detail, right? This is the big one that most people can control. So you can control what kind of detail is at your assembly level. So if I go back to our tire example, when I have that huge assembly open, do I need to see the detail in the tires, the extruded text? Absolutely not. That's just unnecessary detail that's killing your performance of your large assembly. Threads on a fastener, right? Springs, that type of stuff. All of those things are going to be detail killers at the large assembly level. So an easy way to figure this out is probably my favorite tool, and this came out many years ago, is called Assembly Visualization. If you've never used this tool, play with it. Get into Assembly Visualization, and then you can go to, you have to hit the little right arrow and go to More and filter it to Graphics Triangles. And this is basically going to tell you what parts in your assembly are killing your performance from a graphics perspective. And it'll tell you how many of those parts are in the assembly. You would have to do the multiplication. So if you look at that top line, I got a quantity of 8, and each part has 38,000 graphics triangles that are being generated at the assembly level. So that's 8 times 38,000. That's crazy. You know, here's another screenshot of how this would work. But basically, you can filter this down. You can change the colors. You can see exactly on the screen which are the heavy hitters on this. But the big thing is there's kind of some rules of thumb here. These are just things that you know, I kind of stole this from Toby, but you know, really you want to try to have most of your parts be, if possible, you know, less than 1,000 graphics triangles. Now that's just not going to be possible if you do parts that have a lot of contouring to them and things like that. But if you have a lot of flat sheet metal, blocky type parts, there really should be no reason that they're using more than 1,000 graphics triangles. Some parts are going to be in that 1,000 to 5,000 range, but very few parts should be at that 5,000 plus range. Okay, so if you look at the screenshot over to the left, I mean, again, different part, eight of them, 297,000. That's crazy ridiculous, and we want to start doing some investigation. So again, if we look at our tire example, kind of like we did earlier, you're probably going to want to look at suppressing those features if possible. Maybe you need to do some other things, but ultimately what we would like to see you do is start creating a simplified configuration of those. Now the kicker here is and I use this tire as a great example, is to get me all the way to the top level assembly, I got to go through 3 sub-assembly layers, of which I'd have to create a simplified config of each one of those sub-assemblies as well. So your work isn't done just by getting a simplified config at the part level. You know, based on how many layers of sub-assemblies you have, you're going to have to go through this as well. Toby does a nice job, if you have the chance to watch the videos, of going through and how to actually go through and do that. And he actually goes through here and actually looks at, hey, what about other parts that are like, this is the engine block, which is really just a representation of the engine. You know, can you start doing some extrude cuts, some extrusions to start filling in some of the detail? He shows you a really cool tool called Delete Face if you've never used it, where you can start deleting and patching certain features in the geometry. So you can go through and do some of that. So he kind of goes through in more detail some extra tools that you could start using to simplify the geometry, but this is the biggest thing that you can control in a large assembly. You start getting into something of this magnitude and you want it to perform nicely, you really need to start exploring some techniques to simplify highly detailed models down at the big, large assembly level. And that's the beauty of SOLIDWORKS and taking advantage of configuration. So definitely look into doing that. And the assembly visualization tool is the greatest tool to start pinpointing where some of the troublesome parts could be. So again, just I think he spent maybe 30 minutes eliminating some detail on a couple of components, the heavy hitters. And of the overall assembly, he brought the graphics triangles down from 7 million to just under 3 million. And that's for the entire assembly that you see on the screen. You know, really that magic number is difficult to find, right? Because that's really going to be based on some of the video cards that you have built into your actual machines. Somebody might have a great video card, a really expensive card, 4 gig of RAM on board on the card maybe, you know, and your graphics triangle kind of threshold, you know, might be higher than maybe somebody that has more of a mid to entry level video card that maybe only has a gig of onboard RAM, you know, and so you're going to kind of be able to find where that threshold is. You know, I found that my threshold is probably right around a couple million triangles, where I kind of start seeing a sudden degradation in performance of just when I'm using my assembly. So, and I don't have I only have a video card in my machine that's you know, has a gigabyte of onboard memory. So that's kind of a hit and miss target, but you know, you'll kind of figure that out based on the hardware that you've invested in. So get rid of the overly detailed parts, right? Create simplified configurations. This is an absolute must if you want maximum performance of your large assemblies. So I'm going a little long here, but the last section really quickly is just additional tools to really consider for your large assemblies with SOLIDWORKS. So a little known tool is called Simplify. This is something that every user of SOLIDWORKS has access to now. It's under Tools, Find/Modify, and then Simplify. And what this tool can do is actually use some processes to try to do that simplification for you. So you could open like a subassembly. You could then say, hey, I want to do a simplify on that. And it'll actually read through the geometry of all the components in that subassembly and allow you to kind of create those simplified configurations for you. And you can kind of preview things, make sure it doesn't blow any mates up. It's actually pretty slick. You know, the main thing to recognize here is that it's really just looking at the features in the model. It's not doing anything that's going to necessarily say, oh, hey, I don't need some of this geometry even to be visible, like on the engine example, you know. And it won't work if it's an imported model. It's not looking at the like the B rep or the boundary representation. It's really looking at the physical features that you've created in the SOLIDWORKS files. But I would recommend maybe start with a small assembly, run through this and just play with this and learn more about this. But it's actually pretty slick to help you do some of the simplification process. And it's a little known tool that a lot of people aren't aware of. If you are into situations where, hey, you know what, you just need to get this assembly open quickly, we just need to kind of interrogate a little bit. You know, you think about gathering in the conference room and you need to have this design review process. I would recommend exploring opening this file using large design review mode. So this is something that you would flip to before you hit open to fully open that file. It's the screenshot on the left. And then it basically is kind of like a lightweight on steroids, so to speak, where it allows you to do some things, but you're really limited as to what you can go through and do once it's open. The biggest thing is measuring. You can open and do some sectioning, hiding of parts, things like that. But you're not going to be able to start mating parts and things of that nature when open in large design review. But the file will open very quickly. I think I didn't put a note on here, but our Vermeer assembly maybe opened in 10 seconds with large design review. I mean, it's intended to get big stuff open quickly, but highly limit what you can do. We don't go into a lot of detail here, but these are just some other things that I definitely recommend people look at. Some technology that we added quite a few years ago called speed packing. It's basically, again, a watered down configuration that limits accessibility. You know, you can see graphically what it looks like, but you can't really do much digging into the parts in the assembly once you speed pack them. You can also feature freeze or freeze your features. That's more of a part level thing to look at, as well as playing with display states. So we have configurations, but we also have display states. And the big thing with display states is that you can then maybe explore not loading the information of those display states. So again, it can help give you some performance gains, and it'd kind of be like an alternative to using lightweight. So maybe play around and explore some of those a little bit more. So some final action items to consider here is experiment with the Simplify tool. It's pretty slick, but again, it is specific to just the geometry that you're creating with SOLIDWORKS natively. Look at using large design review just to get that really big model open quickly, to do more of, like it's stated, as more of a design review environment. And start looking at other tools. You know, what I probably recommend most, or what I find doing this the longest, now 15+ years here at Fisher Unitech, is, you know, a lot of you out there have been using SOLIDWORKS for many, many years. You don't always transition immediately to the new version. That's okay. But you really want to have someone, a champion or a CAD admin, that's really geared with keeping apprised of what's new in SOLIDWORKS. So these tools like large design review, speed pack, you know, the changes to the performance evaluation tool, these are things that didn't exist when I started using SOLIDWORKS many years ago. So these are things that we're porting into the software, we're developing, we're spending time making them better, optimizing them for your usage. But a lot of times people just aren't aware of them. And so definitely have somebody that's keeping apprised of what's new, what could maybe be useful to you. If you're not sure, definitely come to us at Fisher Unitech, and we'll help point out the advantages. So, you know, just to kind of wrap this up again, like I said, this is really just kind of a high-level summary of a very detailed YouTube series that our buddy Toby Schnaars has put together. You can go on our YouTube channel, search for Fisher Unitech. Once you get to the Fisher Unitech page, go to playlist, and then you're going to find a large assemblies and how to make them faster playlist. Now again, you'll be overwhelmed when you initially see this. There's over 2 hours of video content here. Toby, if you watch the first video, will tell you if you don't have all that time, you're probably not going to sit there and watch 2 hours straight, but he'll kind of tell you what videos you could pinpoint to and get probably the most bang for your time. But even if you're just taking these off, nipping these off one at a time, but I highly recommend looking at this. He's actually showing you how to go through and do this in a video format, and it's very well done, so I highly recommend that. So just to wrap up today, sorry I'm going a little bit long, thanks for hanging in, but the big things to take away from this: get your data local if you can, right? If you're not exploring using a PDM system, you know, that might be something that you should start looking at as well. That's an easy thing to test. Like I told you, pack and go it, open it local. Well, how did it open compared to when you open it across your network? Reduce detail in your file sizes, right? So, you know, larger files are going to take longer to open. That's just how it goes. And so if you have some of these outliers that are just insanely large, try to diagnose why that is. A lot of times it could be detail, things like the image quality maybe is somehow boosted up. Just see if you can investigate why that might be. Keep files to the latest version if possible. So if you're using 2016, 2018, whatever your latest version is, try to make sure that all the files that you're using in your large assembly are up to date to that most latest version you're using. And obviously try to keep them error-free. Settings to optimize in your environment, right? So I mean, I went through kind of maybe the big 5, 6, 8 settings that are going to probably most affect your performance with large assemblies. So you may have to go in there and adjust those based on what you're doing in your day-to-day from a large assembly standpoint. simplify, 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 right? It's probably the biggest check mark on here that you can completely control yourself. That's why I maybe mentioned it 3 times there, but definitely try to simplify the geometry for the large assembly usage, right? Definitely helical items like springs, fasteners, that's a big no-no at the large assembly level, even at a moderately sized assembly level. So you got to go and create some simplified configs of those things. And then I just always put here, always be learning about new tools. Join the Fish Unitech events that we host in the fall. We do webcast series on what's new all the time, and really just kind of pay attention to, hey, what tools and techniques are being enhanced and added to the software that are going to allow you to have a better experience with your large assemblies.